We've got some really good ones coming up, I think. December 10th meeting, a month from now, the main presentation will be LaTeX. How many people use LaTeX? What it is?
L-A-T-E-X.
Good, good.
LaTeX.
Tom, did you have something to say?
It's LaTeX.
LaTeX.
T-E-X or tech, which is the old typesetting.
LaTeX. Will and myself will be working together on that presentation. I don't think we have a second presentation for that night yet, but we're working on it. Stay tuned. We'll post it on the mailing list and the website, and the meetup page, and the Facebook, and everywhere we can. January, we're going back to IPv6. You guys are, some of you were here for the January 2013 meeting. We had Jim Small come in from CDW. He's an analyst there, a contractor there or something. Anyway, he gave us a great presentation on the state of IPv6, where it's at, where it's going, how it's working. He offered to come back again this January to do more of a hands-on kind of thing. I think we're going to set up a small network here and really see it in action. I'm really looking forward to that. It was a great presentation last time, and I think it'll be just as good, if not better, this time. February, tentatively, we've got the Go language. That's the language that I think Google created and put out there, and lots of people are starting to use it now. Mark Ram is going to come talk about that. March 11th, LXC, Linux containers. Anybody know what that is? That's kind of what would you put that in? Virtualization or?
Yeah, it's a virtualization technique tool.
Yeah.
But it's super awesome.
Yeah, Scott Moser's going to come talk about that.
It's like all the benefits of virtualization without all the hardware overhead.
Yeah, without all the overhead. It's pretty slick stuff. And then April, I mentioned my friend from Facebook who has offered to pay for our ads on Facebook. He's going to be in town, and he works in the traffic team for Facebook. He's the tech leader for level 4 load balancing. I was with him last week, about 10 days ago, and he was explaining to me how the load balancing works at Facebook, and it's just incredible. And he's going to come give us a great presentation on that. It should be very, very interesting to see how a large company can actually supply services to. They're up to now like almost 1.1 billion users access the site every month. At any given time, they're feeding like 50 or 60,000 connections per second, which it's just incredible. I think they could teach the health site a thing or two about how to scale. Anyway, that should be really interesting. These presentations that I'm talking about, December and January are pretty firm. February, March, and April are kind of tentative at this point. They may slide around a little bit as people's schedules may change. But that's I mean, we're pretty much booked all the way out to April, so we're pretty excited about that. Refreshments, we do have a cooler here with some, I think there's a couple of waters in there and some pop, and there's some cookies. The deal is you put $1 in the jar, you take a cookie and a pop, or 2 cookies. I think the cookies are going kind of fast. Don't be shy, just get up anytime during the meeting if you can do it quietly, and grab yourself something to munch on. So that takes us right into our first presentation. OpenBSD by Michael Lucas. Michael's a network engineer, systems administrator, martial artist, and critically acclaimed author. He was on the internet before the web existed, and now works for an independent telecommunications wholesaler in Michigan. His recent books include Absolute BSD, 2nd edition, DNSSEC Mastery, SSH Mastery, Network Flow Analysis, and the forthcoming Sudo Mastery.
I couldn't have done a better introduction if I'd written it myself.
In fact, you did. I plagiarized it. So not only does he write books, he writes introductions. So I'm going to turn the stage over to Michael. So, thank you very much.
Thank you, Jim. Hello, everybody. This worked 2 minutes ago.
Use your one chance.
Yeah, but nobody was looking then.
Oh, there you go.
Okay.
That's pretty quick.
So hi, my name is Michael Lucas. And he just covered this whole slide, so we're gonna skip it. So, this talk is on OpenBSD. Let me start off with giving credit where it's due. The OpenBSD folks put all of their papers that they have ever done at any conference up on their website, which I stole liberally from. And some of the more recent stuff came from Theodoret's keynote a couple months ago. I've written this presentation from scratch, and I'm not entirely sure how long it will take. So I've tried to arrange it so you can tell me to get off the stage at any time. This means you should feel free to ask questions whenever. And typos, there will be some. Why am I here? Jim, if you hate this presentation, please take it out on him. So, OpenBSD. What is it and why should you care? It is yet another free Unix-like operating system. According to their website, their emphasis is portability, standardization, correctness, proactive security, and integrated cryptography. BSD, any of the BSDs really, is a complete operating system. It's not a distribution like you're more familiar with in Linux. A BSD operating system is everything. I'm looking around the room, some of you probably were using BSD when it was just plain BSD. BSD as a project goes back to 1979 and is based on original AT&T Unix. If anybody's interested in the history from 40 years ago, I can go into that. But okay, so OpenBSD. What do people know about them from the outside? From talking to people, this seems to be their reputation. They're cranky. They don't support all the hardware you would want. They focus entirely on security, and they're from Canada. And this is what people know.
See, the first one and the last one, they contradict each other. Canadians are generally some of the friendliest people in the world.
Generally, that's an important word. They are the exception that proves the rule. At least according to the reputation. So, that whole reputation comes from their way of doing things. Their license is a pure BSD license, or a modern BSD license. They are absolutely fanatical about doing things correctly or not doing them at all. Another thing that's a little different is that OpenBSD is written for the people who write it, and they put it up for other people to use. But they don't really proselytize. They don't try to get people to switch to the OpenBSD way. Linux users are frequently a lot more open and friendly and try to suck you in. They convince you that the first hit is free and that once it's on your hard drive, you'll never go back. And the OpenBSD folks are more like, yeah, here it is, we use it, it works, it would solve your problem, but if you'd rather have your problem, that's okay with us. They're perfectly happy to sit back and see you struggle with whatever problem they've already solved. And the other thing is, OpenBSD is something of a pressure point for improving the world. And they've done this several times, and I'll go through a couple of those. The big difference in licensing The BSD license, the modern BSD license, yes, it's had a long history, but essentially today, the BSD style license comes down to three things. Leave a copyright notice on the code. We wrote this, don't claim you wrote it. It's fairly common sense for a lot of us, but some companies have had difficulty with this in the past. Leave the copyright notice in the code. If you ship the code compiled, put it in your documentation somewhere. And if you use this and it breaks, don't blame us. We are not claiming it is suitable for anything. But what this really boils down to, there are some distinct philosophical differences between BSD licensing and Linux licensing. The GPL, how many of you have read the GPL? I have read it, and I've tried to figure out how it is a software license. It's an interesting political document, but it's not a traditional software license saying what you can and cannot do with it. That's in there, it's buried in there, but a lot of lawyers make a lot of money trying to figure out what the GPL really is. But really, it's share and share alike, and that's a great thing. We try to teach our kids to share. There is absolutely nothing wrong with that. The BSD license code is more of a gift. As a BSD guy, we don't care what you do with the code. You taking BSD code and embedding it in a product and selling it to people doesn't hurt us, we don't care, and essentially, I look at it this way. A lot of people have very strong viewpoints on things like Microsoft took the BSD TCP/IP stack and put it in Windows, back in the Windows 95 days. Yeah, I see a couple blank looks. There was this thing called Windows 95 that didn't have network support. And there was a lot of discussion on, well, this was just awful, they just stole the code. But turn this around. Imagine the cost in human suffering if Microsoft had written their own TCP/IP.
Or it would have failed and we
Now,
wouldn't have.
we all had enough pain, thank you.
Well, they wouldn't have connected to the network anyway and everybody would have switched. Address Kerberos though. That's, the 95 is one example, but the other one is where they took Kerberos, perverted it.
That is a whole, okay, address Kerberos. Microsoft are cretins? No, okay, a little more detail.
Let's go without saying.
Kerberos is an open authentication standard that is also under the BSD license, and they took it, they embraced it, and they extended it so that you can use Active Directory as an authentication point for Unix systems. But you cannot use Unix systems as an authentication point for Active Directory. Yes, imagine that. That is what Microsoft does. And that played a key role in the antitrust trial, and that's one reason why we now have Samba 4 can act as a domain controller. And Microsoft paid to have that written. So they actually employ various Samba people to work on Samba and make sure that you can use a Unix host as a Kerberos source. So yes, if a company is going to be a cretin, a software license is not the way to solve that problem. So OpenBSD was one of the first BSD projects to completely and truly audit their source tree and make sure that every single file was under this license. And this had some interesting implications. How many of you are familiar with VRP? Okay, Virtual Router Redundancy Protocol. Cisco and a bunch of companies sat down and said, you know, our routers are not as reliable as we'd like them to be. It would be really nice if you could have two routers, and if one of them died, the other router would say, oh, I better take over the default gateway IP. This is not a big revelation to anyone in this room, I'm sure. But they wrote a protocol for it. And the Cisco licensing says, you can implement VRP so long as you don't sue Cisco. From Cisco's point of view, this is very reasonable. Here's this protocol. Don't sue us if it breaks. And if I ran a big company, I'd insist on something like that as well. The OpenBSD code has 3 license terms. Keep our copyright on the source, keep our copyright on the binaries, and don't sue us. Cisco's extra licensing would have added a 4th term to the operating system. Therefore, that's unacceptable. Therefore, the OpenBSD guys would not include would not include VRP in the base operating system. But they wanted a virtual router redundancy protocol-like thing. So they went away and wrote the Common Address Redundancy Protocol, or CARP, and included that. Then they went to the IETF and said, we'd like a protocol number for our redundancy protocol. And the IETF told them, you can't have one because your protocol is too much like VRP. And you should just use VRP. So, there were some choices. They could have used a local-only number, but they chose to use the same protocol number that Cisco used for VRP, which is like saying port 80 is HTTP and it's my special protocol. The interesting thing was when you put 2 CARP hosts on a network with 2 VRP hosts, if, say, you have 2 firewalls next to your 2 routers so everything can fail over, the Cisco routers crashed and died because they saw VRP lacks some fairly basic things, at least back in the early 2000s when this was going on. VRP lacked things like authentication and checksumming. So when it saw these weird packets on the wire, the router just fell over. Cisco now programs VRP at least a little more defensively. But lots of finger pointing over this, lots of name calling. There are people on both sides who say this was great, this was awful. Yes, sir.
Were these implementing the same protocol or simply 2 different protocols with the same purpose?
2 similar but different protocols with the same purpose. The end result of all this, Cisco now supports CARP. Not on all their products, but scattered throughout, where a customer has demanded it, they support CARP. So, another big philosophical point, do it right or don't do it. The people in this room know better. it's not always the operating system's fault. Usually, when something goes wrong, there's an application that went haywire. Somebody did something they shouldn't do. But the truth is, no, it's the operating system's fault. You blame Linux, you blame Windows, you blame whatever. So, the OpenBSD guys say, no, it is our fault. If you somehow crash the operating system, it's our fault. If your program goes amok, it should not take down the machine. But this has a couple of impacts on how they do things. Blobs, binary objects. Vendors provide device drivers as these binary objects for Microsoft operating systems. How many of you have a Linux desktop or laptop with some driver provided by the operating system vendor? Okay, this code is running in the kernel. The kernel doesn't have a huge amount of internal protection against other parts of the kernel. This means this driver really could do anything. It could corrupt the file system. It could send all of your keystrokes to the NSA. Anything. So the OpenBSD guys said, no binary only drivers. We do not support them. There is a mechanism for loading dynamic objects into the kernel, but you have to go through a couple steps to enable it, and they're pretty much labeled shoot foot here. So, non-disclosure agreements are kind of similar. Someone gets an NDA, they write a driver, send it off in the tree, but who's supposed to check that driver? Who's supposed to make sure that driver actually works the way you think it does? I mean, how many of you have written code that you looked at later and said, I don't know why this works. It really shouldn't. Now, I'm a very weak programmer. I do shell and Perl. And I have looked at Perl scripts 6 months later and said, was I stoned? How did this ever achieve the result it gets? So, non-disclosure agreement means it's very hard to audit that code and check it for stupidity versus, no, this is really what the driver needs. Because the hardware vendors have the exact same problem. Sometimes they're not sure how their hardware works at all. So, the target users. This is probably the easiest thing to explain. It's written for themselves. They add features because they need them. They wrote the CARP redundancy protocol because a couple guys were using OpenBSD as firewalls and said, hey, we need failover. We're running on 386 hardware and this stuff is crap. They provide everything you need to actually use the operating system. There is full documentation on the actual system. If this doesn't work for you, there are lots of people who are really trying to suck you in as users. Everyone from Apple to FreeBSD to Linux wants you. They want you. They're just not really willing to do any effort to get you to switch. Because if they need to expend the effort, well, they'd rather be writing code. And if you want a new feature, here's the system source code. Send us a patch. So, you can use OpenBSD for anything you like. You can even use it as a model for suing Cisco. chances are that lawsuit is not going to work, but you can vary it in your product, whatever you want. We don't care. Many people have taken OpenBSD or some other BSD system and used it to create an embedded device. And if you go looking around the world, people from EMC down to home router manufacturers are using some BSD, OpenBSD, something as the heart of their system. So, I have a room full of Linux fans. If you were to go get an OpenBSD CD, plug it in and spin it up, what would you expect? And I messed up the slide order. Yes. Could I have is there some person who'd like to volunteer for a moment? Sir, come here. You're like in good health and everything. Yeah, no major injuries I should be aware of. Okay. Do me a favor and hold up your hands. See, a pressure point is something, it's a term we use in martial arts, where you can, if you're holding someone the right way, you can make them move around and really do whatever you want. And simply steer them however you wish, or, okay? Yeah, okay. So, if this was the body of internet software, OpenBSD is like that. Thank you, sir. Yes, OpenBSD is a pressure point. So, what that really means is, computer research is pretty much dead. How many of you have seen Microsoft actually stop supporting an API? Say, no, we no longer let you do that. Your old software doesn't work. No, it does not happen.
Well, XP.
XP.
No.
No, XP as an operating system is no longer supported, but the APIs that you use to write code. My copy of Office 97 still runs on Windows 7.
Does DeskViewX run? Does DeskView?
Haven't tried. My gut answer is yes. So, there are all these good ideas for improving security, for improving operating systems as a whole. But as long as the old stuff still works the way it used to, nothing really changes. So, how does this tie back to pressure points? We've known for 20 years it would be a really good idea if memory was not allocated in strict stack order. If you were to shuffle things around, you would eliminate entire classes of not just security vulnerabilities, but problems. Buffer overflows would be much harder to do. The compiler support was there, but nobody really wanted to pick up on it because, once again, we don't know why our code works. And there is code out there that at one point depended on actually having internal buffer overflows so that some other part of the process could pick that out. And there was code out there that was just written wrong but seemed to work. And if it crashed every now and then, well, file a bug report. So, the compilers knew how to randomize memory. But nobody wanted to turn it on because all of this third-party software just fell over and died. And it died horrible, unpredictable deaths. Even simple things like WRX, marking a piece of memory as either writable by a process or executable by a process. Well, programs are divided between the executable code and the memory of the stuff that it's actually trying to work on. And a program should never overwrite its own executable code in memory. At least not the majority of software. There are exceptions. Yeah, there are people who are doing really clever things, and
There are exceptions and exception handlers.
yes, there's always an exception. So, OpenBSD said, you know, this is the right thing to do. We're gonna break a whole bunch of third-party software. Went through their own tree, made sure everything worked with memory randomization, did a fresh release, and then turned it on globally. So they had, I believe it was 3.2, no memory randomization, 3.2 plus 1 day memory randomization. And they had a whole release cycle. So, what happened? If they had some kind of memory allocation bug, it broke. OpenBSD has enough users. If you are the maintainer of a software project, I'm going to pick on Emacs here because I actually use it. And yeah, Emacs is a wonderful operating system. If you maintain something like Emacs and you get a bug report that says, I turned on memory randomization in my operating system and Emacs totally crapped out, you're going to go, you're an idiot. Don't turn this on. Everybody knows everything breaks. If you get 300 bug reports that say, Emacs no longer runs on OpenBSD, here is my bug report, you'll take another look at it. And yes, it's the same root cause. The code was crap as far as buffer overflows and memory leaks and all of that. But the end result was it compelled people. Software authors were kind of picked up by this fragile little pressure point and dragged around until they fixed their code. And the result of this was, no matter what operating system you're running, you have a lot fewer of that class of problems. So, you're running Linux, you're running Emacs on Linux, you have many fewer bugs because of this. This dragged the world forward, whether it liked it or not. And as someone who was on the mailing list at the time, they liked it not. And then, once the OpenBSD guys and their users filed all these bug reports and got everything fixed, over the next couple years, lots of other operating systems took the same plunge and turned on their memory address randomization. Most Linux kernels either ship with this now, or it's a sysctl you just turn on and off. So, what are some other things security related OpenBSD has done? OpenSSH, how many of you use OpenSSH? I'm going to assume that people who have not raised their hands are not paying attention.
So how would I know?
Do you use SSH on Linux?
How would I know?
Do you type SSH?
No.
Then you're not.
He doesn't use command stuff.
Use putty? Not often.
When you use PuTTY, you're probably touching OpenSSH. Privilege separation, we'll touch on what that is. New APIs like strl copy and strlcat. stack protection, Portability, which is memory randomization. Spark hardware has this stack ghost feature, which is another memory protection mechanism. Writable or executable memory, randomized everything. So, let's fall back and look at the reputation. Limited device driver support. No blobs. If your vendor will not give the documentation to write a device driver that can be audited by other people, sorry, they're not going to let you load, well, they will let you load random objects into the kernel, but you're going to have to do the work yourself. They're not going to encourage this or help it. It's all about security. Well, sort of, it's about correctness, it's about doing it right, and security is a consequence of that. Cranky. OpenBSD won't support my video code! Shut up. And you know that after they've answered that question after 50 or 100 times, people start to get a little cranky. So, no. Canadian, yeah, guilty. So, part of the reputation, oh, no, wait, yeah, they have developers all over the world. Never mind. So, that's how OpenBSD does things. Okay. So what's in OpenBSD now? I'm going to touch on a couple notable things. Unix-like operating system, it'll be fairly familiar to everyone in this room. The remarkable thing for that you would find coming from Linux is all the documentation you need is on the operating system. You can troubleshoot OpenBSD without Google. Everything is in the manual or in the FAQ. So, if you were to try it, what would really be a surprise? The installer is text mode. Again, it's written for the developers. Text mode is much faster than a pointy, clicky, friendly GUI because you can, I've tried it before, you can hit 8 keys and install OpenBSD. And most of those keys are either enter or Y. There is no official OpenBSD forum. I know that's all the trend these days, but no. There's a mailing list. And interfaces are not named ETH0. They'll have names like FXP0 after the driver for the network card. Another thing that a lot of Linux users find surprising is partitioning. Many Linux systems have 1 or 2 large partitions. Maybe they have slash and slash home to separate the OS from user files. Something like Ubuntu, you just have a single large partition. OpenBSD actually divides the system pretty narrowly for a lot of things. But they also use mount options to protect the system and the user from various sorts of attacks. For example, you should not have device nodes anywhere except on /dev. There's very little reason to do that. If you need them, you can turn it on easily enough. Set UID programs in /temp are usually a bad sign. So, they use the partitioning to protect the system and the user. Okay, privilege separation. How many of you have worked with that at all? Okay. On a Unix-like system, to bind to a low-numbered port, port 1024 or below, you need root privilege. This means that if you have a program bound to a low-number port, like 80 or 22 for SSH or your website or Telnet or anything like that, it's running as root. So if someone can compromise that particular daemon, they've rooted your system. A lot of people write daemons for services that want to run on a privileged port. So the guys at Postfix said, you know, we're going to write a really small program. And the only thing this program is going to do is bind to port 25. And then for all of the actual stuff that the program is supposed to do, we're going to feed it to unprivileged programs running as a very narrowly constrained user. So, you know, if the program you have listening to your privileged port is 20 lines of heavily audited code, it's really, really hard to compromise. It's much harder to compromise than the tens of thousands of lines of code you have for handling your mail or your web server. So the OpenBSD guys said, you know, that's a really good idea. We're going to steal it and use privilege separation on OpenSSH. And now anything that attaches to the network runs with privilege separation. Ping. They have no idea how someone could use ping to compromise a system. But they don't really care. We're going to run this little part as root because it needs to run as root, and the rest of the process just runs as an unprivileged user. If somebody ever does discover how to use ping to root a system, it probably won't run on OpenBSD. And even the X Windows system has privilege separation. OpenSSH I wanted to touch on a little bit more because this is the secure shell server for over 90% of the market. SSH was around in the late 90s. Early versions were under a BSD style license. And when SSH went commercial, they changed the license. A couple people noticed that SSH 1.2.12 was under the last version under a BSD license and said, you know, I bet we could take that code and bring it up to modern standards. And they did a huge amount of work on that. They did a good enough job that they actually had to fend off trademark complaints from commercial SSH. And new features in SSH actually hit OpenBSD first, and then a couple other people extract OpenSSH from OpenBSD. They put some portability glue around it, and they release the SSH that you have on Linux and Solaris and everywhere else. For the record, the OpenBSD guys would really, really like to see a good competing SSH implementation, because it is not good for any one piece of software to have 90% market share. So if you're looking for a project to really make yourself known at, take this on. So, OpenBSD is also highly portable. How many of you have a VAX in your basement? Yes, sir. It runs on OpenBSD runs on it. How many of you don't know what a VAX is? Okay, computer from the 1980s, used at a lot of universities. DEC made them. DEC bought whoever it was that made VAX, I believe. But
That developed that was their own.
You know, I forget anymore. I haven't,
PDP 8, then PDP 11, and the VAC superseded it.
thank you, sir.
VAC sort of cracked the market because before then, everybody who came out with a new, every company that came out with a new, faster computer wrote a new operating system for it.
Right.
VAX was, I believe, the first one to use the same operating system across a wide range of hardwares.
Well, that VAX was very good hardware. Some of it still runs today.
Yeah.
Why is this important? Well, one, porting to multiple platforms makes sure that your code is portable. And two, a lot of people do their development on a nice, fast AMD 64 machine. If they make a change that adds a tiny bit of overhead, you're not going to notice it on the AMD 64 machine. But the guys who are running VAX will go, excuse me, you just host performance. So all of this, things like network stack randomization, they work on a VAX. There is overhead, but it runs on hardware from